All right, let's see if we can apply what we have learned today and what we've learned in the past few days to an area application. So this says we want to find an expression for the area of the blue region, right? So we're interested in the area of this. Okay, so to me we have three things, right? We have the area of the blue region here. Okay, that's the area of all of this stuff inside these boxes, right? Okay, we also have the area of the red region, right? So which is the area kind of right in here. Okay, and then we also, the whole entire thing sort of makes a box, right? Or it makes a quadrilateral, right? So we have the area of this whole entire deal. Okay, so we kind of have red, blue, and black. Okay, so three different areas here. Now, the first thing we should actually do is, come up with some sort of verbal model here that's going to actually help us solve this problem. So we want to know the area of the blue region. So let's maybe write this as area blue. Okay, so I'm going to say area blue equals. Okay, well, we really have two other things to sort of include here. We know that we can express the area of the entire thing, and we can express the area of the red region. Okay, well, the area of the entire thing, if we take that and then subtract the area of the red region, that should give us the area of the blue region, right? So that's what we're going to do. So we're going to say the area of the blue region, and I'm going to say that's going to be equal to total area minus area of the red region. Okay, so it seems kind of simple. Let's kind of look at our picture and see what we can figure out. All right, so the total area, right, when we look at the total area, we have an x and then we have a 3 here. Remember, area is found just by taking length times width, right? And on this side we have another x and then another 3, right? So really that's x plus 3 times x plus 3, right? So I'm going to say the area of the blue and that's equal to, well, the total area is x plus 3 squared, right? So x plus 3 times x plus 3. Okay, again, we could also write that as x plus 3 squared. And then from that, we're going to subtract the area of the red, right? Well, the area of the red, let's take a look at this. Well, for the area of the red region, it looks like we've got 1 right here. Okay, so this has a distance of 1, or a width of 1. This also has a width of 1. This has a width of x, right? So see how this kind of comes up here? This has a width of x here, so that's pretty important for us. Okay, and so this distance right here can actually be represented by x, right? Now I'm going to do a little bit of erasing here. Okay. And so we have 1 right here. All right, and so this side right here, to me, of the red represents x plus 1. Now, what we're really trying to figure out is what is the height of the red area, okay? So when we look at the height of the red area, well, this entire thing is x, right? This is 1. So really, this distance right here can actually be represented by x minus 1. Okay, now again, kind of challenging to come up with that. But now what we can say the area of the red is represented by x plus 1 times x minus 1. Okay, so we have to be kind of careful with how we derive those particular expressions, but in this case it does work. Okay, and so now these are just the special products that we're talking about. So the area of the blue region here is going to be represented by x squared. Okay, so that's again x squared It was then plus 2ab, so that's going to be plus 2 times a times b, and then plus b squared, right? That was the pattern that we discussed, okay? Remember, this is the pattern that we're using, right? A plus b squared equals a squared plus 2ab plus b, that's a terrible b, plus b squared, okay? And so now we're going to go to the red part, okay? And the red part here I have now is x plus 1, x minus 1. So that's the sum and the difference pattern. So that was the a squared minus the b squared. So that's just a 1 squared, okay? And you know what? I'm actually going to put these entire things in parentheses here as well, okay? Because we're taking the entire area of this, and we want to subtract the entire area of this, okay? Now we're just going to do a little simplifying here, okay? So this is now going to give me x squared plus 6x plus 9, and we're going to subtract from that x squared minus 1, okay? And now, this is something that we actually know how to do already, right? So all I'm going to do now is distribute this negative sign throughout here and then combine like terms, okay? So I'm going to rewrite this next part of the problem as x squared plus 6x plus 9, and then I'm going to write, maybe I'll even write this, well, I'll write it in red still, minus x squared and then plus 1, right? Now when we combine these like terms, okay, I know that I've got a positive x squared and a negative x squared. If I add those up, they're just going to cancel out, okay? Now I can look at my positive 6x and my positive 1. Sorry, positive 1 is not like terms of that. The positive 6x, there's nothing to add with that, so I'm just going to say this is 6x. And then finally, I have this positive 9 and a positive 1 is going to give me a positive 10. So this is the expression for the area of our blue region.